Acondroplasia or dwarfism is dominant over normal. A homozygous dominant person dies before the age of 1. A heterozygous dominant is dwarf. A homozygous recessive individual is normal. A heterozygous dwarf man marries a dwarf woman. We have here 4 questions to answer. 1. What is the probability of having a normal child? 2. What is the probability that the next child will also be normal? 3. What is the probability of having a child that is a dwarf? 4. What is the probability of having a child that dies at 1 from this disorder? Let us answer the first question. What is the probability of having a normal child? We will use the Punnett square to find this probability. By inputting the alleles for parent 1 and parent 2 and performing the cross, we can determine the result. The Punnett square reveals the genotypes of the 4 possible offspring. To find the probability, we look at the percentage representation of each genotype. Each box in the square represents 25%, and since we are interested in the probability of having a normal child, we note that the genotype for a normal child is written in 2 small letter Ds, which is homozygous recessive. Thus, from this cross, there is a 25% probability of having a normal child. Let us answer question number 2. What is the probability that the next child will also be normal? The chance of having a normal child is 25%. This is because each child's chance of being normal is the same, no matter what happened with previous children. Let us answer question number 3. What is the probability of having a child that is a dwarf? The chance of having a child that is a dwarf is 50%. And for question number 4, what is the probability of having a child that dies at 1 from this disorder? The answer is, there is a 25% probability of having a child that dies at 1 from this disorder. That's all for this video. Please stay tuned for more, and don't forget to like and subscribe to Study Clips. Happy learning!